So this is the video to show off what I have done for Milestone 2 of Game Engine 2. So to open the engine and get it working, you gotta go into libdev first, standard procedure, make sure this is 86 mode, and then build them all. And of course it says 6 up to date because I didn't clean it. So I go in here, clean it all, and build them. Magic happens. And you go in here, copy the libs, wonderful. Moving on to the engine, which I suppose I should clean the engine out too. And then let us run the engine. So, as you can see, the magic of the animations, voila. 3 different animations for the humanoid, and you got 2 animations for the teddy bear. If you would like to switch the camera between the teddy bears and the human, you press T for teddy bears and H for humans. Now, if you would like to speed up your human animations, you can select the numbers 1 through 3 and press the arrow keys in order to make it go faster, slower, or reverse, or go back to forward mode. So, just showing for the running man, I am going to press the up key, and he is going to start running faster relative to everyone else. And you can see he's doing a mad dash. Pressing the left key will make him go backwards. Pressing the right key make him go forward again. If you hold down, he slows down, and eventually he will end up going in reverse because of how I have it coded. Magic like that. And by pressing 2, you then can speed up the punching man, which I'm holding up now. And now I am going to reverse him, and he's gonna look weird doing that. And I'm going to hold down on number 3 now to make this guy revive from the dead over and over again. Because that's always fun. And then just reverse him back and forth, just for fun. And then the teddy bear, same thing, except now you press 4 and 5. The walking teddy bear is number 4. And the standing teddy bear, which when you go faster kind of looks like he's dancing, he is number 5. So holding up will make him start grooving out a little bit. Magic. And those are the animations. So, just to show a little bit of the code, in game.cpp, right now I have them as globals, which I will fix with an animation manager later. For now, I have it set up that you have camera 1 looks at the teddy, or the human, and then camera 2 looks at the teddy bear. This is just a test object, doesn't matter, but in order to load the animations, you do this and run the load animation on separate animation files and hierarchy files. And you can reuse those files, and then you just replace it with the teddy ones, and those will work. And in update, you just tell them to update, and it works. And the inputs are right here, which are relatively simple inputs, because all it is switch to select the animation, and then make them speed up or slow down, and then switch cameras. So, as you can see, I have these set up as animation objects, which is in animation folder, and it has the general load animation, update. Loading the animation will run set animation hierarchy, set animation data, which just pulls the data from the files as would be expected by going through a loop. For now, you can't change which shader or model it's using, but I can add that in the future. And then it adds max time and adds that as a variable, which you can see there. And the max time is just the algorithm you gave. And in order to update it, you process the animation, you update the local transforms of each of the bones based on the interpolation in process animation, then you set the pose based on the world positions of all that stuff, and then you update the time. Which, the way that I have the time going fast and slow is I just have a variable called playback speed, and I'm just multiplying that against the time down in... That's not it. In update time. It's just the playback speed times that. So the way I have the hierarchy set up is that it'll pass in values with two indexes. One is its own index, and one is the parent index. So I can show the animation headers, which the hierarchy header just is the header of the file, and then the hierarchy info. It gives a name, index, parent index. And then it'll use the function findKnownByteIndex to iterate through the subtree of the PCS tree and find the correct object to attach it to, and then add it to the game object manager like that. And let's see. Process animation is just the normal yada yada in order to interpolate it. Update local transforms is, I'm just making it so that it local updates on the frame head, which I just did this in order to prevent the entire frame from being global, but this isn't that much better because the axis sometimes gives me trouble. Set bone pose is just as you would expect. Find max time. Find node by index. It's just if the subtree is done, until it's done, searches for the index. If not, I have it break because it should always find the index or else something's wrong. And then I just have a couple of extra functions such as setting the width of the bones, turning off the first two animation or pyramids, making it so it doesn't draw them. And then for the humanoid run, I just set all the translation values of y to 0 in order to make him stand still. And then I can go into the game objects, I guess, which you have the rigid object, which is the one that I translate in order to do stuff with. These I need to delete, but not inside the video. Then it's set the translation in order to make it move. It's currently just using this translation, and then I just go search for the teddies for the other camera. And then it updates as expected. And then for the animation game object, I have, instead of the private update, I have this local update, which takes in the frame bucket it's supposed to use, or the frame bucket header, and then it searches, or, no, I was right the first time. Gets the frame bucket, pulls the bone out, and then from that array gets the local transform, passes that in, and then updates the world matrix based on that local. And I separated them because there was the one frame off problem if you update it here instead. So I just had it update from the animation side, and then it'll push the bone orientation into there. And that basically sums up how my animation works.